That engine that you just heard is the sound of freedom. That is a F-35, and God bless America. All right, this video is to show you a hack for finding latitude and longitude using a GEO Brunton azimuth compass. Now, I am not a geologist, so I do not use this compass as it was intended, and that was to find strike and dip and plunge and all that type of stuff. That is what a geologist does in the field to mark a natural feature. Instead, what I did years ago was I purchased this to have a precise method of getting my bearing and azimuth and triangulate my location in the field. And to aid in that, I purchased a tripod, a swivel head here, which is very convenient because this compass has a circular bubble level on top that's really hard to balance with your hands. It could be just me without coffee, but it's pretty difficult. So this just makes it a lot easier. You can rotate this, but the primary thing is just to keep this perfectly flat, right? So you can make the most out of your accuracy. So with this hack of doing latitude and longitude, I'll try and make this very brief. It's very easy to do. And it's very practical if you do not know where you are. It's very impractical to a prepping situation where you think the world's going to end. What I would do in that case, if you really need to know where you're going, is just get a road map. If those are hard to find, you might have to order those on Amazon. Used to be get those in a gas station. But just have a road map, because chances are during a situation, an apocalyptic situation, you're always going to cross a road somewhere, right? And as long as you just had a basic compass of a general direction, hey, I just want to go north, regardless of what my magnetic, reading is, that'll get you generally to where you want to go. I think during a apocalypse, you're going to see a lot of shopping carts on roads anyway. So that's going to be the new highway, is the shopping cart highway. So this is more of a hobby for me. And I love to play a mental game where, and the game is this, all right? I don't know where I am in the world. So how am I going to use this material right here to find my latitude and longitude, right? So that's how I approach this, because even though I have a general idea of where I am as I transit about in the state that I live, I don't have a ballpark lat lawn onto a map, okay? So this allows me to do that. If I ever went into the middle of Death Valley, am I really going to be concerned about my exact Latin lawn? Not really. I think a topo map might be the best thing to have, or even just a latitude longitude map, because it will identify certain features. So again, this is a hobby. It's fun for me, and let's get on with this instead of me just sitting here rambling about just the love that I have for this instrument. So, all right. So to find latitude, that's very easy to do. What you're going to do is you're going to set this up due north. I happen to be at a 36 degrees latitude. All right. So I know that being the 22nd of June, there is a solar declination of about 22.4. If I didn't know what day of year it was, or I didn't know what the declination was, then I would refer to a static chart that I made here. On my right is a solar noontime for GMT within the nearest minute, right? Because these values do change, but they don't change that great over time. On my left is the declination of the sun. And what I did, I put this together for day of the year, and depending on where the sun is, you can either add or subtract that value from your inclinometer reading here as you get the angle of the sun at solar noon. And that's how you find latitude, is by using this solar declination chart. Now, the accuracy of this is within seconds. So for fun, I went into the NOAA website, I entered my coordinates to determine and make this chart here, and I went out to the year 2050 just to see what the error rate would be. and it's only within a few seconds. So I'm like, hey, this is cool. I could update this every 25 years and be happy. So, but for the practical application of what we're doing, that's the information that you have to have. Okay, so you need a good precision watch. This here is a GEO Oceanus. And what I love about this watch is it updates itself automatically about 2 or 3 times a day through radio transmitters that are positioned in various countries around the globe. So it has an automatic update feature. Also, it has different time zones. So I can pull the crown out and I can rotate it to GMT. And that's what I do in the field, is I make sure that my watch is always on GMT. Because again, get back to the mental exercise. I do not know where I am in the world. Do I have to add a time zone or subtract a time zone, right? It just gets me into the habit of using a very good mechanical means of finding latitude and longitude and getting to be very good at it. So, and you kind of want to train yourself, or at least I do, to a very rudimentary approach of how would I do that if I didn't know where I was on the planet. Okay, so for finding longitude, you're not going to know what your meridian is. Your meridian is the north and south longitudinal line at solar noon, right? But there's a very good rule, right? If you know what solar noon time is, which we have here, right, within the nearest minute, then what I can do if I don't know what my local meridian is I'll set my instrument up more than 30 minutes before solar noon time, okay? And the reason is I'm going to be either east or west of that hour line, okay, of one of those 24-hour time zones at every 15 degrees. You got 15, 60, 90, and so on. So I know that I have 30 minutes of play before or 30 minutes after of one of those time zones, okay? So hypothetically, let's say that, well, let's not do hypothetical. I have the chart right here. So today is the 22nd of June, and I refer to my declination chart, or I'm sorry, my solar noon chart. And for this day, let me find it, June 22nd, GMT is 12:01, okay? So that means that where I am, I happen to be near 120 degrees. That means that my solar noon at 120 degrees longitude is going to be 12:01, okay? So I will set up my instrument at about 11:30. And what I'm doing is I'm aligning my instrument due north, and I'm going to track the elevation of the sun until it gets onto my north line, okay? And how I'm going to do that is I'm going to use this long forward arm here, sighting arm, and I'm going to use this line on the mirror. Now I have my mirror covered up with a protective pad, but that's a mirror with a line on it. And what I'm doing is I'm capturing the ray of the sun coming down. It's going to cast a shadow onto the line, okay? I'm going to record the amount of time that that shadow stays on that line. And you would be surprised how long a shadow can stay on a line when you're waiting for it to get off the line, right? But the reason for that is the curvature of the Earth. So if you have the sun directly overhead, it's going to appear to move faster, right? If you're at an angle and you're capturing, I call it solar lag, it's going to just hang out for a little bit, right? But you can find out the time of that just by, okay, it got on the line at 12:01 and 10 seconds, and it moved off the line at 12:01 and 30 seconds, right? So what I'll do is I'll half that time, I'll split that lag time. And with that split lag time, I can then deduct it or add it to the 12:01 solar GMT time. And when I do that, it's going to give me a value. It's going to give me a time value. And then I'm going to convert that to DMS, minutes and seconds on a map. You could also convert to decimal. I prefer DMS because that's just how I train myself. So I'll do the math on that, and that's going to give me my local meridian. And you'd be surprised how accurate this method could be. So I'm going to get out into the field in July. I will do a practical demonstration. This here just discusses the concepts of how you can hack your Brunton into a latitude and longitude tool. So this is the Cold War Sailor. Thank you for watching this video. Out.